Hello everyone, my name is Luis Jimenez and today I'll be giving a presentation on line values for model interpretability. In the next few minutes, we'll cover what line is, why interpretability is crucial in deep learning, walk through a hands-on example, discuss limitations, and finally wrap up with key takeaways. Now let's get started. First, what is line? Line stands for Local Interpretable Model Agnostic Explanations. At its core, it approximates a complex model locally. For a single prediction, say an image labeled as cat, line generates slight perturbations, sees how the black box model outputs change, and fits a simple surrogate model, often a linear regression model that's easy to inspect. Because it treats the original image as just a function you can query. It works with any algorithm, hence model agnostic. Now, why does line matter in deep learning? Deep neural nets are notoriously opaque. If a loan approval network rejects an applicant, stakeholders demand to know why. Line shines a light into that black box model by identifying which inputs drove a decision. That not only builds user trust, but also helps data scientists catch bias, which is critical when regulations mandate an explanation for every decision. Moving on, let's work a practical example. Let's say your ResNet model classify an image as the label cat. Line will chop the image into superpixels, randomly mask some out with these patches you see here, and it see how the confidence of the prediction changes. If hiding the ear drops the label cat confidence sharply, that region gets a high weight in the surrogate model. We then overlay a heat map where bright or red areas show that the models paid attention to this specific area in the image. And then you can immediately see which parts drove the label, the cat label prediction. Now let's see what are some of the challenges of Lime. While Lime is powerful, it isn't perfect because it relies on random perturbations. Two runs on the same instance can yield slightly different explanations. And remember, the surrogate is only valid locally, meaning it might not generalize beyond the neighborhood of that single example of that single training instance. Finally, if your base model is huge, repeatedly querying it hundreds or thousands of times adds overhead. To wrap up, Lime is an accessible way to peek inside the black box models on a case-by-case basis. It's not a silver bullet, its explanations are approximate and stochastic, but it's an essential tool in the interpretability toolbox. If you like further readings on the matter, read the paper by Ribeiro and colleagues or fire up a live video. You can check out the original research paper titled Why Should I Trust You, written by Ribeiro, or you can go to the official GitHub website. Lastly, in the example overlay of the tabby cat image, which region did Lime show to have more importance in the predicted label? Thank you so much for listening. Have a good one.